from that warm-up, you can see that now we're moving on to vertex form. We know how to find the x-intercepts. We know how to find the y-intercept. I'm going to erase some of this, actually, because I think it's nicer to see the step-by-step. So we're going to prove right now that these are the same. We're going to expand it, okay? We're looking right here. Do you see that? The goal is to show that these are the same. Do they look exactly the same right now? Well, I got some similar numbers and stuff, but I'm going to take this, and instead of x plus 2 squared, I'm going to write x plus 2 plus x plus 2. Everybody good with that? Yep. Okay. If you don't do that, you're likely to get it wrong on the quiz. I'm just letting you know. I'm going to distribute my x and get x squared plus 2x. I'm going to distribute my 2, get 2x plus 4, and then I got a minus. Don't forget that minus 4. What do you know has happened with these 4s? They're canceling. And I'm left with x squared plus 4x. Which means that f of x and h of x must be the same. You follow? So the reason that we're learning this new one again is I know that according to this, my y-intercept is 0. I know according to this that my x-intercepts are 0, 0, and negative 4, 0. Because it's right here. It's the C term of standard form. I got the x-intercept by 0 times junk is 0, and negative 4 makes that 0 times junk is 0.
Oh, wait. Oh, it's the same thing?
These are all the same. Yeah, look at this is x squared, 4x.
Oh, I didn't know that.
Yeah. So now this one, I'm not going to tell you how yet, but this one is going to involve the vertex. What I would like you to try to do with your partners first, though, is instead of just taking my word for it, I want you to prove that these are the same. Okay? Here's a little hint. I want you to prove that those are the same instead of just taking my word for it. Let's go. So, number one place most students will make a mistake on here still is not expanding out their x minus 3. Okay? So I didn't actually do anything to solve it yet. I just rewrote my function as x minus 3 times x minus 3 because that's what x minus 3 squared means. We good? You remember, like way back in the day, I was like, this is the number one thing kids mess up. The next thing, it doesn't matter what you do next, actually. I'm going to choose to distribute my x's and negative 3's next. Don't lose that negative 1. And I get x squared minus 3x minus 3x plus 9 plus 4. Okay? Now, I kind of do this short step right here where I kind of circle this and just acknowledge that that's a negative 6x. Sometimes I'll rewrite the whole thing with that as a negative 6x. It's up to you what you would need for organization, but everybody sees that thing I circle is a negative 6x.
Yes.
So now I choose to distribute my negative 1 to those three things, which would give me negative x squared plus 6x minus 9 plus 4. No parentheses anymore. I've distributed everything, which is negative x squared plus 6x minus 5. And this is this. And if you did this as well, you would also get the same thing, okay? So again, we know that this gives us the y-intercept easy. It's negative 5. This gives us our x-intercepts easy. It's 5 and 1. And this is going to give us our vertex easy once we figure out a couple things. Yeah, that's what I just said, once we figure out a couple things. Okay. So I'm going to copy and paste here, I think, something. Wait. I'm just going to rewrite it. I might need you to help me rewrite it. Next slide. I'm just going to lose stuff I want from this slide on the next slide. So we already did this. We showed that R and P are equivalent. Now here are the graphs representing the functions from graph H and R. So who can read me that last one, H, from our warm-up? Who has it on their paper for me? Yeah, can you read it to me? Actually, I can just do it. I know something, so I can just do it. I don't know why I was asking for it. Okay. Is that right?
Yeah.
Okay. Just make sure I'm right. Okay. So, these are the vertex form functions. It's your job to figure out how these functions work to give us the vertex. Like, you're going to look for a little pattern. Then, I just want you to look for a pattern, and then I'm going to explain why the pattern works to you, okay? So right now, with your groups, try to find a pattern. Remember, what point are you looking for, probably? Vertex. Let's go. All right, Bob, explain to me what you're seeing on that graph of H.
Okay.
You can point to it and stuff.
So, you see this number right here?
Yeah.
+2.
Yeah.
This means that you have to go instead of +2, you're going to the -2.
So you're saying this +2 right here is telling me to go left 2.
Yeah.
Okay.
Because the X is negative.
And then you see this -4?
Yeah, right here.
So this means that you go down.
Down.
1, 2, 3, 4. Right
So if I'm here and I go left 2, down 4, I'm right there? Okay, let's test this out. So with that theory, this would tell me to go
Positive 3.
right 3. Let's try that out. And this would tell me to go
Up 4.
up 4. Okay, so let me do my best to explain to you why this works. So this is true. This is how vertex form works. Also, I forgot to point this out. This part right here makes me go down. The negative. Because that's going to give me a negative A term. Okay. It is. It's actually for the same reason as the absolute value stuff.
Because like with a positive.
Yeah.
This is exactly.
We're going to go with the reason after I rewrite my R of X that I just erased. Okay. Here's the reason. I'm going to write a lot of different parabolas here. So just be ready. You ready, Finn? My first one, I'm going to do our base parabola we've been using. X squared. Okay? Everybody go with that? 0, 0 is the y-intercept, 0, 0 is the x-intercept. Now, right now, it's zeroed out to be 0. If I want to move it left 2, I would need to go x plus 2. Because to get this to 0 out, what would x be? Minus 2. That's my shift 2 left right there. Okay? So as soon as I make it x plus 2, that puts me right here. Then this constant, just like when we did standard form, this constant at the end, how did that constant always shift me? Up and down. It's not involved with the square portion. That's how I go down 4. Cool, huh? Yeah.
So square next to the parentheses, the 2.
That's what makes it quadratic.
So left and right.
So this is vertex form, right? And it's the same as all the other forms, right? But the other forms, which I probably can get just from the graph even without some help, 0 and then -4, right? That was good for finding our x-intercepts. And then x squared plus 4x was good for finding my y-intercept. If you use all three, you got like all the main parts of your parabola. That's why there's going to be 3 forms. Raymer.
How do you tell if it's going up or down?
Yeah, that's great. So do you remember when we had ax squared plus bx plus c the other day?
Yeah.
This number right here determined the width and whether it went up or down, right?
Also, if it's a negative.
This negative right here, right? If I were to simplify this whole thing, I'm missing my square there. If I was to simplify that whole thing, I would have a negative x squared, right? So that's why. Good question.
Yeah, so like.
On the left side to see if you can find it.
Yeah. It can't be inside the parentheses, right? That's something I saw earlier, because if it was this, guess what happens when you do negative x times negative x?
It's negative x. Or x
It's positive then. So this would not give you down.
So
It has to be outside in vertex form.
So if it's a negative, it would open that.
Yeah, just for the same reason that it worked with this. Not a new reason, right? And I did like someone pointed out, it is very similar to what we did with absolute value functions, right? We shifted the 0. Do you remember that? Yeah, cool. So I think I'm feeling pretty good where you guys are at, but I still want you to practice this Desmos. So, well, actually, let's start by writing down the definition here. This is the definition of vertex form. I think you kind of are understanding it in general, which is good too. I just want us to have this down. HK is the vertex, okay? So this is just saying where the vertex goes in the form. You're going to want to write down the definition just in case you need to reference it later. I'm going to go actually back to the previous slide, and let's talk about how these things were changing things. So, this number in here, in general, how did it move our graph?
Left and right, left and right.
Left and right. And it's zeroing it out, right? So it depended what this number was to get this to cancel it to zero it out, right? So kind of like when you subtracted, which way did it send you? Right. When you add it, it actually sent you left because you're zeroing out. Don't just memorize opposite, even though that is true. It's kind of zeroing it out. This K right here, how did that move us?
Up and down.
Up and down. Kind of just like the C term because it is a lot. This is not the C term because if we were to multiply this out, the C term would be something else, but it's a constant just like the C term. So once we shift the X left or right, then it shifts it up and down. And then what about this leading coefficient A there?
And when it like flips upside down.
Width and flip.
Wait, does H and X control it left and right, or just H?
Just H. But the X does because the X variable is what determines where the zeroing out happens, kind of, right? It's because of the X. Let's go to this table, and you can, next slide. You can write it down with me. Or just follow. I think you'd be good following along. I'm feeling really good with where you guys are. So, this tells me where? Negative 10 on my left or right, and then this tells me where? 0. Does it go open, up, or down? Up. A is positive. Okay, next one. This sends me
-4.
4 to the
4 to the right.
to the right. This one sends me 8 up. Open, up, or down? Up. Okay, I'm going to give you 2 minutes to talk through the rest of these with your group before I give you answers. So here, we've got 4 right, 8 up, but this one opens down. Here, I've got 0 right, 7 down. This one opens up. So I just want to point out, this one is actually both standard form and vertex form because x minus 0 squared is the same thing as x squared. Everybody see that? Okay. Next one, we go 3 left, 5 down. It opens up. The half, is that going to make it more narrow or less narrow? Less narrow. It's getting bigger, slower. Okay. Next up, we go 100 left, 50 up. It points down. So what this one is saying is, x is always needing to be the opposite of m. Then we have n, send us up or down. And a depends. Depends on positive or negative, right? Positive goes up, negative goes down. Just like the other day, the A term, okay? Same A term. Cool.
Is A of n always going to be the variable used for the quadratic function?
AX squared plus BX plus C, and then, yeah. All right. Cool it down with the summer. I think this will go pretty quick. Careful when you go to the basket to get homeworks because you and the 8th graders are at different days now. All right? So make sure you grab the correct one.